Okay, let's begin the experiment. Here the aim of the experiment is to find the refractive index of a glass slab using traveling microscope. So this is the traveling microscope, and the principle is refractive index of glass slab respect to air is equal to the ratio of real depth by apparent depth. So this is what I have written. So refractive index of glass slab is real depth by apparent depth, which is equal to R3 minus R1 divided by R3 minus R2. So basically R3 minus R1 will give me real depth, R3 minus R2 will give me apparent depth. Now what is R1, R2, R3? So see here, as you can see, there is a dot there, some dot. Now if you could see that dot through the microscope and through the air, that's R1. If you could see the dot through the glass slab, that's R2. R3 means you have to put some chalk paste powder here, and you should focus on the chalk paste powder, not on the dot. That is R3. So that's what I have written here, R1, what is R1, R2, R3. Then the second formula is least count of the traveling microscope. The general formula is 1 main scale division divided by number of divisions on the secondary scale. So as you can see in the instrument, there are two scales. This is the first scale, which is the primary scale or the main scale, and this is the secondary scale. Here the secondary scale is vernier scale. Now what we have to do, we have to calculate what is 1 MSD, that means 1 main scale division. So what does it mean? You can see that there are many divisions here. So if you take 1 centimeter, that is 4 to 5 centimeter, in that 1 centimeter there are 20 divisions. So what is the value of one division? So obviously it should be 1 by 20, because as you can see here, 0 to 1 centimeter, or you can write anything here, 4 to 5 centimeter or whatever. In that span of 1 centimeter, there are 20 divisions. Basically 20 divisions covers 1 centimeter. So the value of one main scale division is 1 by 20 or 0.05. So that's what I have written here. Then number of divisions on the secondary scale, that means the number of divisions on the vernier scale, there are 50 divisions. So 0 to 0.1 there are 10, so 20, 30, 40, 50. So there are 50 divisions. So if I substitute that, I'll get this least count of the traveling microscope, which is same as screw gauge, which is 0.001 centimeter. The third formula is total reading. Why total reading? Because we are adding up two readings, one reading from the main scale or primary scale and one reading from the vernier scale or secondary scale. So that's what I have written, main scale reading plus coinciding vernier scale division into least count. We already know least count. In this experiment we will be finding what is MSR and CVD. And this is the observation table. Basically you have to do R1, calculate R1, R2, R3 twice. So that means first you have to calculate R1, R2, R3, and then again R1, R2, R3, then take an average. Now how to start the experiment? Before starting the experiment, you need to take two precautions. So the first one is you have to make sure that the microscope is level. You can make sure you can change by turning this. So if you turn this, you can make the instrument level. Then you have to make sure that when you remove this eyepiece or magnifying lens, basically you should be able to see the dot without magnification. So as you can see the dot there, that is without magnification. Basically I'm just confirming that the microscope is properly aligned. Then I will put the magnifying lens. Now what you have to do, you can loosen the microscope so that it is easier to lift the microscope, and then you have to keep looking here and then lift the microscope until you see the dot. So it's hard to see through the mobile, but for me I can see the dot. So you can also see. So I have basically lifted the microscope and now I can see the dot very clearly. So this position is now R1. Now how to measure R1? So basically we have two parts, right? So total reading, you can see here total reading is MSR and CVD. I want MSR and then CVD. Now how to measure MSR? So as I drawn here, this is the vernier scale. You have seen already, this is the vernier scale, and the number of divisions on the vernier scale varies from 0 to 50. Now this is the main scale or the primary scale. There we have already seen that 1 MSD is 1 by 20 or 0.05. So each division is 0.05. So if for example, if this division on the main scale is 7.50, the very next division should be 7.55. I have just added 0.05 because one division is worth 0.05. So this is the situation. Now how to measure MSR? MSR means the 0 of the vernier scale is where on the main scale. As you can see, the 0 of the vernier scale is between 7.50 and 7.55. So the MSR should be 7.50. You have to take the lower value. Then what is CVD? So CVD means you have to search some division here which is exactly coinciding with the main scale. So maybe here somewhere this division is exactly coinciding with the main scale division. Maybe that division is 21. So that's basically 21. So as can you see here, 20 here is coinciding with some division of on the main scale. 30 is also coinciding. So in this situation you have to take the lower one. So the CVD should be 20. Now this is the genuine actual way to calculate. The approximate way is, I have already taken two readings on the main scale, 7.55 and 7.60. These three cases, 1, 2, 3, they represent the 0 of the vernier scale. So this 0 of the vernier scale is represented by these three. So for the first example, let's start with the second example. The second example, it is exactly in between 7.55 and 7.60. So basically for all three examples, MSR is still 7.55. And what is CVD? CVD is this length, this height basically. So you can clearly see that for the second case, which is exactly in the middle, CVD should be 25. Why? Because we already know that CVD varies between 0 and 50. So the average of that, or the midpoint of that, is 25. So basically for the second one, CVD is 25. For the first one, CVD will be very much less than 25, maybe 5 or 10 or something like that. For the third case, CVD will be more than 25, maybe 45, something like that. So there is some kind of human approximation involved here. If you cannot do through this method, you can approximate also. So now we are measuring the R1. So hope you can see that 0 of the vernier scale is above 6, you can see that, and each division is 0.05. So it's 6.05 and so on like that. So now let's take the value of R1. So you can see that the 0 of the vernier scale is above 6th division on the main scale. So you can see that this is 6. So 0 of the vernier scale is here. So now we have to count how many divisions above 6 this 0 is. So if I can count, it's 1, 2, 3, 4, 5, 6. So this is the 6th division. So basically 0 of the vernier scale calipers is 6 divisions above 6. Now we already know that each division is 0.05. So 6 division means 0.3. And for that we have to add 6 because it's 6 divisions above 6. So my MSR would be 6 plus, because 6 was the base value, and 6 into 0.05. Now why is 6 into 0.05? Because 0.05 is the value of each division, and the 0 of the vernier calipers was 6 divisions above 6. So basically it's 6 into 0.05, which gives me 0.3, plus 6 would be 6.3. So that would be my MSR value. Now I can, from the approximate method, CVD I'll write it as 10. Why? Because this was 6 and this was the 0 of the vernier calipers in the just now we saw that. This was 1, 2, 3, 4, 5, 6, 7 and so on. So the 0 of the vernier calipers was between the 6th division. So this is 1, 2, 3, 4, 5, 6. So this is the 6th division. So the 0 of the vernier calipers was just above the 6th division. So maybe this was the case. So that's why I'm writing 10. So now the total value we can just calculate using this formula and you will get the total reading. Now this is the second reading. Basically I've just kept the glass slab. Now again I have to look, try to find the dot through the glass slab. Now initially I couldn't do it. So what I did, I just lifted up the microscope by loosening the screw here. I lifted up the microscope until I could see the dot clearly and then I tightened the screw. Now again we have to see what is the value of MSR and CVD. Okay, so here you can see that the 0 of the vernier calipers is just below 7. So basically my 0 of the 1 year calipers is between 6.95 and 7. But it's very closer to 7. So what can I write? I can write, so this is the situation basically. This is 6.95 and this is 7 here somewhere. So my MSR is 7. So my MSR is 6.95. So my MSR is 6.95. But what is my CVD? Definitely it's above 25. So maybe it's 40 or something. So that's my MSR. So now this is the third reading. So basically I have put some chalk paste powder on top of the glass slab. Now again through the microscope I will see. Maybe I will have to lift the microscope again. So at this point I could see the chalk paste particles very clearly. So now again let's see what is the value of MSR and CVD. Okay, now you can see there that the 0 of the vernier calipers is 4 divisions above 8. Now CVD is 0 because you can see that the 0 of the vernier calipers is exactly coinciding. So CVD is 0 and the MSR is 8 plus 4 into 0.05. So why is that? Because 0 of the vernier calipers is 4 divisions above 8. So my MSR value would be, for the chalk piece, the last reading R3 is, I could see 8 and the 0 of the vernier calipers was 4 divisions above 8. So this is my MSR. So that would be 8.2. So that's my MSR, 8.2, and 0 was the CVD because it was exactly coinciding. Now let me calculate what is eta. It's R3 minus R1 divided by R3 minus R2. So R3 is 8.2. So in the numerator it's 8.2 minus 6.31. So that will give me 1.89 divided by R3 minus R2. So again R3 is 8.2 minus R2 is 6.99. So I'll get 1.21. So if I calculate that, 1.89 divided by 1.21 is 1.56. So we know that the refractive index of glass is 1.52. This is a crown glass. So the refractive index is 1.52. We are getting 1.56, which is close enough.